your focus area for small satellites?
Particularly, so I have a mechanical engineering background, and a lot of my experience back when I was at NASA had to do with mechanical engineering. But having experience in robotics, it turns out that's a very interdisciplinary field. So you have to know how to write software, you have to know how to build circuits. And in the end, space you can never be a one-trick pony in space. Our ships in the Navy operate far from land. And so to communicate with these ships, we have to leverage airborne and space-based assets. Without space, our Navy could never do the things that it does. We navigate the oceans with space-based assets. We have meteorological satellites that help us plan the routes that our ships take and keep our sailors safe. And there's also from intelligence gathering, and they help us. Space-based assets that ultimately help the Navy do its mission.
What do you, as one of our younger professors and scholars and experts, see as the future of space in 5, 10, 15 years?
Well, it's a very interesting question, and being involved in the research and development phase of small satellites, in a sense, we have to be able to try to predict the future because ultimately we're building it now. And so these actually all unfurl in space. This has a full communication system and a flight processor and attitude control system in it. And if you notice actually out here on this on the side, there's an open space, there's a hole. And that open space is where you can fit in an experiment or a payload. And so this is primarily what we try to expose the students to, is the development of the experiment, the integration into the space vehicle, and then ultimately once it flies, the operation of that experiment.